In this video, we are going to tackle another example where we are solving a system of two equations and two unknowns using matrix operations and achieving reduced row echelon form. So our system of equations is 5x plus 3y equals 9, and then 2x minus 4y equals 14. So under solution, we're going to follow a similar process that we saw in the previous example. We're going to write this as an augmented matrix. So we're going to have 5, 3, 9, and then 2, negative 4, 14. And then we have a partition line separating the coefficient matrix from the constants, okay? So the first thing I would do is I would notice that the second equation here, which is represented by the second row here, each entry is a multiple of 2. So what we can do is we can perform this row operation and we can say 1/2 row 2 to change row 2. So that way we essentially like factor out a 2 and cancel it. That's kind of what the equivalent of what we would be doing to the second equation. We're killing off one of these factors of 2. So row 1 hasn't changed. We still have 5, 3, 9 here. And then row 2 becomes 1, negative 2, and not 14 anymore, but 7, okay? Now, the next thing we need to do is what? Well, maybe pause the video and think about it, and then, I'll tell you after you hit play again. Okay, let's say you hit play again. The next thing you want to do is interchange row 1 and row 2, because notice we have a 1 in this entry, but what we really need is to easily get a 1 up into the top left entry. So the easiest way, the most convenient way of doing that is we can say interchange row 1 and row 2, okay? So let's take a look at that, all right? So when we interchange row 1 and row 2, we've got 1, negative 2, 7, and then 5, 3, 9. So what have we essentially done? It's kind of like we just, wrote the equations in a different order. It would be kind of like if you wrote this equation just on top of this one, it doesn't make any difference, right? So let me make this bracket look a little nicer here. All right, so what do we do next? Well, we have a 1 exactly where we want it to be. Now we need to somehow work towards getting this 5 to a 0, getting this negative 2 to a 0, and getting this 3 to a value of 1. Again, we want reduced row echelon form. So what can we do next? Well, again, what I do is I try to get the lower triangle to 0 first, okay? So I'm going to say negative 5 row 1 plus row 2 to change row 2. Again, what I tend to do is try to get the lower triangle to a 0 first. So what does this become? Well, again, we're using row 1. We're using row 1 to change row 2. We are not actually changing row 1 at this point. Notice my nomenclature here, to change row 2, okay? So I'm keeping row 1 the same, but I'm modifying row 2. So I say negative 5 times 1 is negative 5, plus 5 creates a 0 here, okay? And then I'm going to say negative 5 times negative 2 is positive 10. Positive 10 plus 3 is positive 13, okay? And then I've got negative 5 times 7 is negative 35 plus 9. So negative 35 plus 9, what is that? That's going to be negative 26, right? Negative 35 plus, I'm doing my mental math, yeah, negative 26. Okay, so we're getting there. We've created a 0 in the lower triangle. Is this row echelon form yet? No, we still have a 13 lingering here. So how about we do this? How about we perform another elementary row operation and we say 1/13 row 2 to change row 2. So all we do is we're multiplying row 2 by a non-zero constant. Notice we are not doing anything with row 1 here. We keep row 1 the same. What does row 2 become? Well, it becomes 0, 1, and negative 2. Okay, so what is this form right here? Well, we can make a note. This right here is row echelon form. It is not reduced row echelon form yet. It's just row echelon form at this stage. All right, what do we do next? Well, we're going to perform another row operation, and we need to create a zero entry right here, okay? So what we're going to do is we're going to say 2 times row 2 plus row 1 to change row 1, okay? And again, we're using row 2 to change something about row 1. So that means, is row 2 gonna change at this point? No, row 2 is gonna remain the same, just like this. But what happens to row 1? So we've got 2 times 0 plus 1 is 1. And then we've got 2 times 1 minus 2 is 0. And then we've got 2 times negative 2 is negative 4 plus 7 is negative, no, not negative, it's, positive 3, okay? And that's it. So notice that this right here is reduced row echelon form. Let me spell that a little better. Reduced row echelon form, okay? And again, this gives us our exact answer. So the final answer is x equals 3 and y equals negative 2. The system is consistent, and that concludes this example.